Hello, and welcome to What's the Word, a podcast linking together electrical trade and industry members. I'm Jason Cox, and together with Zach Hartle, we're having relevant and informative conversations with members of our industry.
With us here today is a guest who really couldn't be more passionate about solar PV energy. This is Nathan Ward. He's with the Crestview Group. He's the Renewable Energy Manager here in Calgary. He's got a really diverse electrical background, commercial design, instructing actually, and then finally now finding his home in the renewable energy sector. So welcome, Nathan.
Hi, guys. Thanks for having me.
Absolutely. So with the show, Nathan, it's a little bit of two parts. First part, we want to know, tell us about yourself, your background, what do you currently do, why you're in the electrical industry and passionate. And then we're going to have you, talk about solar PV energy a little bit. And we have some questions for you on that. So, take it away and let us know how you got to where you are today and what still drives you in the industry.
Sure. I'll try and be quick. So I first thought about electricity, I think it was around Christmas when I was pretty young. My sister was plugging in the tree and she grabbed both prongs, plugged in the lights, and then started to cry. So that was my first experience with electrical. Didn't think about it much until later. Then started working in different trades, getting exposed to different construction, framing, drywall, plumbing, mechanical, concrete, all kinds of things. And then started helping out with a little bit of electrical. And like, oh, I don't know anything about that. Let's see where that goes. So I started an apprenticeship with Pyramid Corporation, worked in their panel shop. It was a great place to spend the first year and a half in the trade. Working under a roof in the hot summer in a building, better than on a roof, which like now in solar, but we'll get there. So did that for the first year and a half in the trade. Then I worked for Crestview Electric doing commercial installations. That was fantastic. I worked with Crestview until I got my journeyman ticket. After I got my ticket, my uncle, who had recommended me to apply at Pyramid, told me that I should come work for this engineering firm he was working for, because they want someone with field experience who understands how these electrical components go together, is basically the wording he used. So he asked me to come along and throw in a resume. So I threw in a resume, got a job working for them. So I had a great time working for them, got to learn AutoCAD and do well site design work, as-builting. Got to go across country on the Energy East pipeline, see some really interesting old equipment. That was pretty cool. So did that for a couple years, and then I worked at SAIT, teaching the apprenticeship program and helping to develop the solar course. That was a lot of fun. Then I felt the call of industry and had to get back to the field. So I came to Crestview Electric, again, where I now run our renewables division, CVE Solar. So focusing on solar, but I do have little side projects like our turbine here behind me. So.
All right. So I like that, but what drew you to solar? So you came to SAIT, you were instructing at SAIT. Was it just happen chance that you built the solar course, or was there what got you into, the solar PV industry? What makes you passionate about that specifically?
I think solar is from my training at SAIT that most got me interested in it. So one instructor I had back when I was a third year was really passionate. I could tell he was invested in the trade. And I think it was in one of the third year classes. Somehow we got talking about solar, and I was just fascinated by it. And not a lot of the third year curriculum addresses solar, so I went off on my own and just devoured any resources I could find about learning about solar, and I've tried to get that different training. So I've taken several courses over the years, and again, developed that course at SAIT to help keep solar alive in Calgary. And yeah, just it's an interesting technology. Like no moving parts. Like sun hits it and you get current and voltage out. It's pretty cool to me.
It's really interesting. Like like you said, I mean, we take it for granted now. I mean, everyone's been using solar powered calculators for 20 or 30 years, but now to see this actually being used as an actual energy source versus just our standard generators that we've used in the past, or hydroelectricity in other provinces. Yeah, it is quite interesting. And I mean, you happen to just dovetail into this industry almost at the perfect time. And that's not to say that you were able to latch onto it, but it was people like yourself that really got this movement going. And I mean, lots has changed over the last 10 years. It just seems to be building and expanding, and it seems like we have these new installs throughout. Well, for our purposes here in Alberta, there's solar installs being done on grand big farm scales all over the place now to supplement the grid. So good for you for having that energy and being one of those contributing factors. Now you're one of these subject matter experts of solar, whereas and it was all just from your interest and hard work of researching this project. So good for you.
So, I mean, that's excellent, right? All these opportunities came to you, and now you've landed in your spot as the renewable energy manager. And as Jason just mentioned, right, solar, it's changing and it's growing and it's evolving, and it's, the last decade we've just seen an enormous exponential growth and uptake of solar. Where do you think it's headed? I mean, do you think it's headed more towards smaller scale, or do we see these farm scales being, I guess, the future of solar, a mix of both? What are your thoughts on the future?
I mean, it's absolutely, of course, going to be a mix of both. It's not like we're going to stop doing home solar or stop doing farm solar. They're both integral components of the future grid. I see homes and businesses being critical in stability for the grid, being able to offset your loads on site, mitigating the need for transmission and distribution upgrades in grid support, those non-wires alternatives that you can get, whether that's solar or solar and storage in the home or in the business. That's going to be huge for grid support, especially on with hot summers like we're experiencing with this heat wave right now.
This is like right now, this is the hottest weather record we've ever had in Alberta. I look outside and there is not a cloud in the sky. Like, solar people must be just rubbing their hands together with the clear skies, that bright sun. But I mean, obviously there's a little bit of heat there too, right?
Yeah, I mean, yes and no. Solar installers always love the summer, right? It's better than getting on a roof in the middle of February. But yeah, no. So the interesting thing about solar is like the actual technology is with the silicon solar cell, you've got a negative temperature coefficient, so you actually get more energy out of it, more power, more higher voltage when the cells are cooler. So if you've got a sunny day and it's relatively cool, and versus a sunny day and it's relatively hot, that cooler day is going to produce a fair bit more energy.
So we're looking at bright sunny days at 15 degrees Celsius. That's more of a happy day for you guys.
Yeah. Right now you'll see a little bit of a dip from all that heat. I mean, it's not going to be ridiculous. It's not like you're cutting the energy production in half, but it is there.
Quite a bit better to work in 15 degrees Celsius too than I mean, we're 8:30 in the morning right now and it's 25 degrees. So
yeah, it was, I mean, in environments where these temperatures are normal, the construction workers are starting at 4 a.m. so that they can go home by midday. I would think that's something would almost be necessary right now in this heat wave.
Yeah, absolutely. I'm glad I'm not much on the day-to-day management of the field, guys, because this would not be the most fun time to be outside.
Okay, so when we're starting to look at the future here, one of the questions I have is, um, if we move towards these solar systems on roofs and residential occupancies and stuff, and with the changes coming in the EV in the future, um, how are we going to be able to plug in our cars and have solar in our house and still not exceed that maximum OC on the breaker in your house?
Well, it's all about when you're using that energy. Um, so anybody, even if you're not in the electrical trade, if you go look at your home electrical panel and you add up all those numbers on the breakers, it's going to be a lot more than the number on the main breaker, right? Your main breaker, average home, you're looking at a 100 amp main breaker. If you add up all those breakers underneath it, you could theoretically draw a lot more energy than that main breaker can handle. But you don't have all your circuits fully loaded all the time. There's different factors at play there. Now, with with regard to the solar and EVs, it's all about timing. So if you're able to charge that EV during the day, for example, in this last year, if you've been able to work from home, if you've been lucky enough to do that, and you can charge that during the day off your solar, you're essentially getting free fuel for your vehicle. So there's going to be a ton of different challenges for that future grid, whether it's uh, more nimble utilities charging different time of use metering, time of use rates, pardon me. So those different time of use rates can incentivize charging at different times. Uh, Historically, what your service from the utility hasn't been really quantified well. Are you entitled to up to 100 amps, 120, 240 all the time, anytime? Or does the future utility model say you can draw 3 kilowatts between this hour and this hour, and 5 kilowatts between this hour and this hour, and et cetera, et cetera? Do they give you new limits? It's going to be a really interesting time to see how that moves forward. I think one of the key drivers there is going to be advanced metering infrastructure, smart meters, things like that.
Well, and that makes sense, right? That would be a lot cheaper than having to replace uh, conductors. I'll just put it as simple as that. So yeah, with different ways and different metrics is, I mean, it's very similar to what they're doing or they have done in Europe for years, right? It's not unheard of for people to be doing their laundry late at night in Europe, right? Just because of a rebate on the lower energy cost at that time. So you don't want to be you don't want to be running your um, all your air conditioning and trying to charge your electric vehicle at this time. That might be difficult.
Yeah, absolutely. But I mean, if you can give people that price signal as to and transparency as to what they're paying and how much energy they're using, then they can make better decisions for themselves and financially, and better decisions for the grid as a whole. Helps us mitigate the tragedy of the commons with any kind of infrastructure project. So
That's a great point. Yeah.
I did see an interesting uh, case study. I think it was a year or two ago. Fortis and I believe U of A did a study on one feeder section, and they simulated uh, essentially it was one transformer and feeding kind of a community, or one substation feeding a community, a little bit of business and residential. And I think they simulated a 2% adoption rate on electric vehicles. And they said if we get past that 2% adoption rate, then that feeder section would be overloaded and need several $1 million in upgrades. So that on its own is a relatively scary thought. But if we get to a place where we can get that advanced metering infrastructure out there and give people those price signals and the ability to better control their loads, then you can definitely offset or postpone some of those upgrades, or perhaps even postpone them until they're not needed, because by the time you get to a place where you absolutely would have to make those upgrades, maybe we're in a scenario where we've got higher quality, lower cost home energy storage systems. whether that's hydrogen and fuel cells or battery storage or whatever else.
Yeah, well, I mean, battery storage is the big kicker now that when we start talking about solar and renewable, right, is that a lot of people don't understand that uh, the big cost comes from those batteries for sure. I also liked how you kind of you mentioned a moment ago about just informing people about um, just the metering and the monetary rates. I mean, basically, you just have to change a behavior, and I mean that happens naturally with adults when they move from being an adult to a parent, and we turn into our parents and run around and turn off all the lights
Yeah.
because that behavior is in place because we know that if we shed the load, right, ideally our power bill would come down. The behavior is also being marketed now with car insurance to a fault where people are ridiculed for driving slow to the hospital or whatever. But it's like I need to keep my insurance rates down. So I guess with some education and some changes in how we meter, yeah, maybe there's hope there.
So, I know we've talked about this, and you're working on some of these, more farm scale solars, right? That are now contributing to the electrical grid in the province, and they're participating in the electrical pool here. And I mean, we could talk for hours about how electricity is quantified and billed in Alberta, of course. But what are these? What does a farm scale project look like? From start to finish, what steps go on? I mean, there's got to be a huge design phase and
How do I start? I guess first it looks like a field,
yeah.
big field. Then it looks like a field with a bunch of stubble sticking out. That stubble is piles, so big chunks of metal, I-beam typically, driven into the ground. So that's going to support your racking system. So it's this big. So we're talking 5,000 foot view. What it looks like. So it'll start to look like field with stubble sticking out of it, and then you'll see more and more job trailers coming in as more trades start to come to site as after the pile driving is complete. So pile driving is then complete, or one section of it's complete. It kind of moves in waves. It's an interesting progress relative to traditional electrical work. Like you can't think of it like a commercial building. You almost need to think of it like a factory, right? It's like an assembly line. You're doing one piece at a time, and then you're moving down the line, doing the next section and the next section and the next section. So yeah, starts out as that empty field, piles get driven, then the racking crew comes in. A lot of the times on these farm scale solars, the racking crew seems to be carpenters or laborers doing that installation. It's interesting because generally as electricians, we install most of our own racking system, and when we think of racking system in general electrical, maybe we're thinking of a bunch of unistruts to hold up pipes, and we think of that as a rack. When I say rack, I'm talking about the solar mounting system. So one particular project we're working on, I won't mention the name, but is using a tracking system. So there's two common types of solar racking for farm scale projects. You have fixed tilt, which, as the name sounds, is fixed in one direction and not moving. And then you have tracking systems. Trackers can be of two types. They can be dual axis trackers or single axis trackers. So single axis trackers, typically you'll see the piles in north-south rows, and the panels are going to track from east to west throughout the day. So tilting and tracking the sun throughout the day, trying to be as close to perpendicular to the sun as they can get. That'll give it fairly significant energy yield increase. So yeah, so racking crew comes in, those carpenters start installing the racking system, and then they'll have what they call a glass crew come in. These sometimes are electricians, sometimes are not. Generally, though, they should be at least supervised by an electrician. So yeah, so those guys will come in and take the solar modules out of the pallet, lift them up, put them on the racking, bolt them in place, and away you go. Then you have your solar module with its DC leads hanging below, sitting there. Definitely, definitely need to be supervised. I wish I could share this picture. One of my guys sent me from that site. It's like he captured it. You have one job, and the solar module was on the rack, but they had crushed the one lead in between the racking and the modules. So mistakes can be made even on simple tasks. Anyways, sorry, off topic. Yeah, so once you've got the glass in place, this is where the electricians start to really come in. So this is where we would be running our DC cabling along the racking system, fastening into it. So on this project, I think we got strings out of 25 modules. So how deep do you want to get into, like, just?
Yeah, that's okay. So what, like with 25 modules, how what kind of DC voltage would we be talking about then?
Yeah, so we're sitting a little bit underneath 1500 volts DC. So really, really good, really relatively high voltage there. Something most electricians aren't exposed to or working with unless they're in the solar industry. It's pretty interesting to see. The actual connectors and things you're working with are pretty simple devices. Easy crimp connection, finger safe plastic connectors. Yeah, it's real interesting. So anyways, once the modules are hanging there, you interconnect them one to the next, and then you have string cabling that goes to one end of that row of 25 and the other end of the row of 25 modules. And then we bring all that wiring from all these different strings back to what we call a combiner box. So that takes the individual strings operating at 1500 volts and brings them together with a bunch of other strings. And so if each string is operating around 10, 11 amps or so, now we're bringing them in with 29, 30 other strings into a combiner box. Now we've got a lot more current available at that location. So from there, we've got all that 10 gauge wire from the strings coming in, and then we're heading out of that combiner box with, of course, a much larger wire, because as we bring them together in parallel, current adds. So we're heading out with whether it's a 350 or 500 or 750, all depending on length for how much volt drop we're going to see in that cable based on how far it is from the inverter skid. Back from the combiner box to the inverter skid, you've got all these 500s and 750s coming in from the different combiners. And then you've got your inverter skid where you have all your DC coming in from all the combiner boxes. Out of that inverter, we're of course using the inverter to convert from DC to AC. That will then typically go into a transformer and then step it up to a medium voltage. So some of these inverters are really interesting. They're not typical voltages like we see in general electrical installations, not 120, 208 or 277, 480 or 347, 600. Sometimes you'll have real oddballs like 800 volts AC. But anyways, that doesn't matter so much because it's generally directly connected to inverter to a transformer, and then that transformer distributes out back to the substation at 25,000 volts or 35,000 volts, just to minimize your losses there. And then from the substation, you're bringing in all the energy from all these different inverters on site. So we've gone from string level back to combiner to inverter to substation, and substation back out to the grid. It's a pretty cool process. The other electrical work I guess I didn't really mention is the trenching portion. On these solar sites, there's generally a lot of trenching. On another option different from trenching, we have an overhead wiring method. It's not really overhead, but it is above ground. There's a few different brands, but basically it's generally a copper-clad steel cable, and to that you'll have these little hangers you'll attach on every meter or so, and then you take that string cabling and you can hang that in there. You can take combiner box cabling and hang that in there. It's really neat to see. Completely different wiring method from what most of us were exposed to in general electrical work. Most people have done trenching at some point in their trade, but this is very different. So But other than that, like it's relatively simple connections. You're just doing it thousands and thousands of times. So yeah. And as the project goes together, each of these steps, they have different commissioning things and tracking things. It's very organized. There's a lot of reporting that needs to be done, a lot of commissioning testing, a lot of current testing, voltage testing, all these different specific steps to make sure that everything's done right and consistent. Because whenever you're doing something thousands and thousands of times, that's when people can get complacent, mistakes can be made. So there's lots of different strategies we try to use to mitigate boredom and make sure those simple mistakes don't happen.
So when, like, just from my point of view and my experience when it came to big scale electrical installs, I mean, we typically worked with a general, and all of our design came right from an engineering company, right? So when you guys go to do the commissioning here, obviously you're working with an engineer, but you yourself, when you're designing your systems, do those designs have to then also go to some sort of engineer for validation, or how does that work?
Yeah, it definitely varies project to project. So I do design projects as well. Mostly my designs have been commercial, a bunch of residential as well for solar design. But yeah, typically I start out with my design. So I look at the roof surface or building surface or field or whatever we're doing, and try to work from my solar fundamentals and figure out where we can get the best energy harvest, how to best support those solar modules, and start from there. So once I figured out that, then I work backwards and say, okay, electrically, what do I need? How much energy am I going to get out of this? And then I take that information and then take it back to the service. How am I going to connect to the service? What size of conductors am I going to need? How much am I allowed by code or allowed by different wire service provider regulations? How much can I feed into this service and still get it through the permitting process? And then when the engineering comes in, not needed on residential projects, but it is needed on most large scale commercial projects. Generally, we, if it's not a pre-engineered project and I'm just doing the install on, but if I'm doing the design, I would do the design and then send it off to any engineering company that we feel like currying a little favor with, and they review my designs and sign off on it. Sometimes it will have a little comment, a little back and forth, a little discussion as to why I made certain design decisions. But generally, people have been quite receptive. So,
And then another question I have is, once again, most electricians, we are taking the utility power and supplying a load, which is a building typically of some sort. You are providing the power to the utility. So I'd imagine there's some interaction there between the installers of the system and then the utility. Is that correct?
not a lot between the installers and the utility. I mean, certainly there will be a little coordination with metering if there isn't appropriate metering infrastructure in place. But generally, most of the interaction with utility is done way back to the design stage and permitting stage. So not a lot of field interaction, but you do get to see a lot more of the utilities connection to the building than you might if you're just a typical service electrician or coming in after the utilities connection. It really gets you an ability to see into the distribution equipment a lot better. So it's fun and interesting in that way.
So you were talking about during the install of this farm scale, right? There's portions done by laborers and there's portions done by electricians. And I know based on some conversations we've had in the past, this is it's a point of debate and a point that you're really passionate about. But where is that line between work that can and should be done by laborers and work that can and should be done by electricians? And what's your thought on that line and if it's in the right spot?
I mean, I don't know if it's in the right spot right now. It seems that the government has taken a stance that racking installation doesn't need to be done by electricians. I fall on under the camp that the racking install absolutely should be done by the electricians. My reason being, uh, we're responsible for the grounding and bonding of all equipment we touch, right, guys? So if we're responsible for our grounding and bonding of that equipment, that's an electrical connection. So we should be the ones making it. Does it make sense? Do electricians want to do that racking installation? I mean, you're working with heavy metal all day long. Uh, so some of it's depending on if it's a punched and rolled system or things like that. Can have sharp edges. Does the average electrician want to work on that? That's another question. I'm not so sure they do. Um, so it's kind of a toss up. I would obviously like to protect the trade and have us be responsible for that work. But whether or not the field guys actually want to do it, that's an interesting question. Uh,
I think it has to do with where we are in the economy. I mean,
exactly.
in my lifetime, I've seen. I mean, obviously, I've been through a couple of booms and busts now, or seen the cycle. Maybe not multiple times, but there was times where electricians could afford to be a little picky on what they wanted to do and where they wanted to work. And then in recent times, right, the amount of work has not been there for the mass community of electricians. So I think, yeah, like you're saying, I mean, it's the same with anything. What I mean, this is electrical, right? So there's always that one job that maybe you don't want to do, but if there's nothing else to do, then for sure, right? Then
Yeah,
maybe we'll do it. So yeah, if we could get, obviously we want to always have the most electricians working, but you can understand sometimes why they're not.
yeah, and there's definitely been a little bit of difference in the this most recent crop of apprentices and willingness to work and what work they're interested in and what work they will just don't seem to be interested in doing. So, um,
Yeah, I think that's definitely changed a bit. I remember digging trenches for a year and a half before touching a piece of conduit or anything like that. So,
yeah, or maybe you touch conduit every day, but you're just the guy who brings it from the first floor to the fifth floor.
that's right.
It's yeah, the start of apprenticeship for some people is very different than the start for others, and that's something we all need to do better at to try and keep people engaged and try and get the apprentices thinking of it like a career, not just a job, right? I'm very fortunate in what I've been able to do with my career and the ways I've been able to move, but it's all on the back of being an Alberta journeyman Red Seal electrician, not no other special skills, just just an electrician at the end of the day.
Yeah, so I mean that's a good point, right? You've really taken advantage in your career of exploring new opportunities, searching for new things. So I mean, if there's people listening or people out there who come to you and ask, like, what should they do if they're interested in learning more about solar or working on solar? Is the electrical apprenticeship would obviously, I mean, be our recommendation here as three electricians, but
Absolutely. Obviously, we might be biased, but
yeah. Anything else they should be looking at if they're trying to get into solar, or is it just, search out for solar companies and apply? Or if someone came to you, what would you want them to have? Yeah.
basic electrical knowledge and work ethic is all I'm looking for. 2 feet in a heartbeat, and you want to show up for work. It's the work isn't that hard. If you're on a solar farm, absolutely can be monotonous. Like there are certain jobs that just have to be done, right? You need to strap that wiring. So you're going to operate tie wraps for 3, 4 weeks, 8 weeks, 12 weeks, depending on what crew you're on. But we try and rotate guys through. We try and give you interesting jobs. Um, yeah, I guess my advice to the new apprentice or young electrician: ask questions of your foreman. Say, hey, why are we doing this? I mean, definitely, certainly pick your timing, but ask questions. Be enthusiastic. That's it's got me a long way. I definitely wouldn't have the skills I have now if I didn't ask questions.
And I think that's something that maybe has become lacking, I guess, in the last few years, just talking with people is, and I'm the same way, is, you know, you got to ask questions. Why are we doing this? How come we're doing it this way? Is there other ways of doing this? Right. And just asking those questions it's key to learning, right? As we all know. And like you say, asking at the right time. I remember always my journeyman had told me, you know, if you got to talk to the foreman, it's based on how fast they're walking. If they're walking really fast, it's not the right time, right? Because they're probably going to put out some kind of fire somewhere. So,
Yeah. Yeah. Reading the room.
yeah, absolutely.
So Nathan, I've got a heartbeat and I've got 2 feet. I think that's how you put that. Um, as a parent of a young adult, if my son or daughter was interested in pursuing a career in electrical and was interested in the solar, how would that look if they wanted to apply for a position with your company? Like,
Yeah. So good question. So I guess for my philosophy and Crestview's philosophy, how we try to treat our apprentices, I try not to have solar specific people. I don't know if comes from my time teaching or it's, I mean, it's just how I think. I want you to be a good overall electrician, not just a solar installer, right? It's one trade, not 2 trades. So um, I would try come apply to us. We may get you on a solar project right away. We may get you on a general electrical project. Could be commercial project. You could be assisting someone in the service van. All kinds of different projects. So we would, number one, get you indentured, get you safety trained, and then you'd be out on a site working. Uh, Again, 2 feet and a heartbeat, but also the other thing I mentioned, enthusiasm. Show up every day, ask questions, and you will go far in this company. So enthusiasm and a positive mindset goes a long way.
and a pair of steel-toed boots and some tools, I
that
guess.
too.
Yeah,
Goes with the
yeah,
safety gear.
absolutely. All right. Is there anything else you'd like to add there, Zach?
No, I think that, I mean, that comes down to, you know, again, the accountability and the integrity of the trade, which is really part of the messaging is, you know, why we started this podcast is what makes the trade great and what can keep it great so that it doesn't shift away from that. You know, it's given all of us so much and we just want to give that back, right?
Yep. And I think one way we can keep the trade strong is just keep being enthusiastic, keep caring about the trade, and get more people in who care and encourage those who don't to leave.
Well, you definitely, I like your point today about asking lots of questions, right? We need to have conversations. Everyone needs to be informed, right? And that can only help to make our trade stronger. And yes, it's not, we don't want to have just one segmented, I install solar, I install pipe, I'm the guy that digs the ditch, right? Yeah, you need to be refined and know how to do everything. And a lot of that comes from practice.
Yeah.
So there's a lot of repetitive jobs out there, and hopefully you're you're refining your skills so that you know what you're doing, right?
Absolutely. Just practice, implementation, and trying to try as many different things as you go through your apprenticeship, for sure.
Well, I'd like to say on behalf of Zach and myself, thank you so much, Nathan, for being with us today. And we'd like to thank our listeners for joining What's the Word podcast today. We'd love to hear from you. And if you like the show or have any suggestions for us for a future episode, we greatly appreciate that. Make sure that you leave us a review, reach out to us on Instagram, or comment to let us know your thoughts. Once again, ask questions, talk to us, right? We would like to make the industry better. We like to learn. Hopefully you like to learn. We'll be back every second Monday with a new episode for you. Make sure you subscribe, and thanks for listening.
Thanks for having me, guys.